What's up, everybody? This is Matt Brown with another IoT hacking video. Today we're taking another look at our Hikvision security camera, and today we're going to be performing a firmware modification that will allow us to get root access. So let's go to our computer and discuss the details of this firmware modification that we're going to attempt. So if you remember last time, we already performed the chip off firmware extraction on this device, and we were able to obtain this user data.bin file, which is the large file that we get out of our flash reader. So we copied that over from our Windows side to the Linux side of our system here, and you can see it's a pretty large file. It's 7.3 gigs, right? And so this file, what we're trying to do, if you recall from our earlier videos, is we are trying to modify the U-boot environmental variables to update the Linux kernel parameters and boot into /bin/sh. So I'm going to talk about that because I've actually attempted this once before, and I ran into a major problem with a CRC check, and so we're gonna kind of go through all that, and we're gonna reattempt this firmware extraction, and hopefully this will all work. So let's talk about that in my thought process. So first, what I'm gonna do is I'm just gonna look where in this firmware image we want to perform a modification, and then I'm actually gonna just do a little bit of analysis on that file. So first things first, let's go, and I'm just gonna use XXD. It's just a command line terminal-based hex editor, and I'm just going to pipe that into less and then search for boot arg. So over here we can see that this section starting at hex 50,000 here is the offset in the firmware image where we find our U-boot environment. And so you can see here, and what we discussed before was the modification of this, not the boot command variable, so the boot args variable, and specifically this init parameter that's sent to the Linux kernel as a command line parameter, and it's set to LinuxRC, which is the init system. It's like the first userland program that the kernel executes to kind of hand over execution responsibility from the kernel to userland in a typical Linux system. However, we want to change this. So we want to actually boot into /bin/sh so that we get dropped a fully privileged shell and not that restricted shell like we had before. So let me show you what happens. I have in a text file the UART output of what happens when I just change this part to /bin/sh without updating something else. So I'm gonna just pull up another terminal here, and I believe it's UART log. Oh, I've got that file open somewhere. That's funny. Oh yeah. I've got it over here. Okay, so here is our file log, and all of this looks familiar except for this line right here in the boot up process. It says, warning, bad CRC using default environment. So clearly there is a CRC check. So that's a check. It's a type of checksum. So it's doing some kind of a hash, or it's much weaker entropy than a hash, but it's doing some check of all the bytes in the U-boot environment, and it's saying, hey, this is not what I expect, so I'm just gonna fall back to some kind of default environment. And because of that, I wasn't able to get my shell. So this led me down a trail of learning about U-boot, and so on this post, somebody's basically saying like, hey, I got a bad CRC check on one of these things, and he's trying to understand, and they're like, yeah, the CRC is the first 4 bytes of that environment section in U-boot, and so they're saying, yeah, it's the first 4 bytes, and it's a CRC, and I think somewhere else in this article or elsewhere, it's detailed that specifically it is a CRC 32 check, which makes sense because 32 bits equals 4 bytes. And this is all lining up with what we saw in our file over here. So again, just send that away for now. See, so here we see this first 4 bytes that are not ASCII is right here. So it's B311 ECCA. So that is our CRC32 checksum that if we're going to update another part of this file, then we need to update the checksum to match. And so we need to understand how this CRC checksum gets calculated. So first, I want to share a kind of a cool tool with you. So what I'm going to do is I'm actually going to take this user data file and I'm going to parse out a section of it. So first of all, I just need to do this real fast and get the integer value of that hex offset. And then we're just going to use dd to carve out relatively the place where we want to edit this firmware. So the in file is the whole firmware file, and then we're going to just output it, and we're just going to call this uboot env.bin. We're going to set the block size to 1. We're going to say skip. That's our offset, and then let's just read 1,000 bytes. That's fine. So I want to show you this cool tool that somebody recently wrote, a friend of mine, Sharon. He's a great IoT and embedded hacker, and so you should definitely check out his work. But he created this tool, hex.pov.sh, and so it's kind of cool because I can just open up this file. And it's just a hex editor because anytime you're doing like hacking or reverse engineering on, whether it's a binary protocol of bytes going across a network or it's a file type like this, it helps to be able to highlight things, right? So I can highlight this and I can say, hey, blue, I could name this section, I could name this, CRC32, and it would identify it as such, or I could go down and I could start to label, the parts that I want to modify. I will note here, like, it's just a small bug, but the ASCII representation is not reflecting properly with a hex 20 byte, or which is a space in ASCII. So that could be fixed. So, but if we go here, we can easily highlight the section that we're going to. I highlighted way too much, didn't I? Yeah, why did I do that? Oh well, you get the idea. Yeah, let's take that away. Here. Bam. That's what we want to edit. And then you can also note things in the file, like we talked about. This is actually a null terminated file, so you can see, or excuse me, not a file, a string. So this variable, this whole boot args variable that starts here down to here is null terminated, and we discussed that we do kind of get a little bit of wiggle room, because what we don't want to do with our firmware modification is increase the file size, because then we get into a whole bunch of other problems. So what we want to do is we just, again, want to modify this, and then what we can do is we can add an extra 20 byte here, an extra space, and because we're looking here and there's more than one space in between these different parameters that are passed to the kernel, and the kernel must be fine with more than one space separating kernel command line parameters. So we're good to go. We get a little wiggle room. That's nice. I just wanted to show you this tool. It's kind of cool. But let's go back over to our firmware modification and get it prepped. And to do this, actually, I'm gonna drop the links to this in the description. But I actually, through the information that was shared on this website, and then kind of digging through the uboot source code here, I actually developed a couple of Python scripts that I'm going to use. So the first Python script, what it's going to do is it's going to determine what the size is that we need of the uboot section that we need to perform a CRC checksum over. And the way we're going to do that is kind of through brute force with the existing file, with the original firmware file. So we know we have a good checksum in that original file, and we can go through and add more and more bytes to our CRC checksum. And so that's what this is going to do. So this is kind of a cool script. So it's going to go through and it's going to progressively read in 1 byte of data, and it's going to keep calculating the checksum, and it's already read the first 4 bytes of the file, and so it knows what the checksum should be, and so it's going to continue, and then it's going to determine what this this U-boot config environment size variable, because different hardware platforms, they do actually change this variable right here. So that can differ. Like I think the default Raspberry Pi image is like 1000 hex hexadecimal, and then we're going to see that this one is quite different than that. So that's what this tool does. It's just going to brute force what that size is. And then we can use that size for our second tool to then calculate, whoops. So my second little tool that I've written here is just to calculate the U-boot CRC, where you pass it the offset into the firmware file, you pass it a size, and you give it a file. So we are going to do that all right now and just discuss how I did this firmware modification successfully. So the first thing we're going to do is, so I already have mine here that's already done, and it's actually already flashed onto that chip over there inside the reader because it takes forever. So we're just going to call this like test.bin, and then we're going to do our firmware modification where we replace Linux RC with bin sh. And as someone pointed out in a YouTube comment on the previous video, this could be naive because there could be more than one instance of Linux RC. So a pretty easy way to check this, in fact there isn't, but we could check this by saying, oh gosh, dang it. I pasted that. I did it on the wrong file. That's funny. Okay, we got to do it on test. But I'm going to get prepped vbin diff on test, and then the original. And I can hit enter, and I can see that I can hit enter again. And just trust me on this because it's going to take a while, but it will scroll all the way to the end, and it will show us that this edit in this part is the only change that is made between our modified firmware and our test firmware. So we're not going to let that finish. But we have to do one more thing, because now we've changed the kernel command line parameter, but now we need to update the CRC. So this is where these couple of tools that I have written come into play. So this tool, you need to pass it an offset and a file. So the offset, as we kind of discussed, is that. I made my tool so you can specify it as a decimal or hex, and it'll convert it properly. And we're going to look through the original firmware file. So now it's going to try all the sizes, and it's going to see if there's a CRC match. And in fact, it found it with this variable set to 20,000 hex. And then next, what we're going to do is I'm going to use this other script that I have to calculate the U-boot CRC, and we're going to pass in, let me just show you the help. So here we need an offset, and then the size, and then the file. So offset, same as this. The size, we just figured out with the other tool. And then the file is going to be our modified firmware. So here we're going to do test.bin, and it's got a problem. Oh, yeah. Paste the script in there. There we go. All right. So here it's telling us that it's read the current CRC, which, as we saw before in the firmware image, that is the existing CRC, but that's not correct anymore. And then it calculates one. So we need to go into the firmware and put the proper CRC in place. And so we are going to do that with this really long sed command. And so obviously this is using sed with raw bytes to look for that raw CRC and then replace it with the new one. And we're going to do that inside of the test binary. And that's going to do that. And then we can reuse vbin diff again to check that out. And here we can see that we have the change here in the checksum. And if we scroll down, we will see that we also have changed Linux RC to bin sh. So now we have our two corresponding changes that should align to a valid U-boot environmental variable part in the flash. Okay, so that is good. it's all ready. And then what I did, I'll show you the steps I took, but I already have this flashed because it takes about 10 minutes for me to transfer the file from my Linux machine to my Windows laptop over there, and then it takes a while to flash the thing too. And so what I have done here, a wonderful RDP session, is I have transferred the file, and then I have gone ahead and reread in the firmware. So here in the XG Pro software, we have got this read into user data test 3. And so every step along the way, I've been running checksums to make sure that the firmware, like that the SCP transfer to my Windows machine is good to go. And then I flash the firmware to the device. And the way I did that is that I came down here and I actually went to this single user area data file, and then I selected my modified firmware and flashed it to the device. Now the reason why here it's set back to user data is then I again reread the firmware in back with the reader, and then ran another checksum. And so you can see here, that's what I've been doing all the time, is just running MD5 sum on these firmware files to ensure that here you can see in this terminal, it's really small text, but you can see that the checksums match for the modified firmware and the user data, which is when I did my read back. All that to say is we now have our modified firmware with just those few little modifications back onto our flash chip. Let's go over to the bench. That's a lot of explanation. All right, so we do not need this anymore. We've got our flash chip hot off the presses. All right. And what we're gonna do is, so there will be some flux involved in some of this process, so I'm gonna get some gloves on. Don't like that stuff on my hands. All right. And then I'm gonna set this to the side, so we are going to have to clean off the flux on here. And before we do our BGA reballing and reattaching of that chip, but we'll do that in just a second. First, what we're going to do is we're going to prepare this chip with some new solder balls. So right here is something I have not used on the channel before. So this is a BGA stencil that is specifically set up for this chip, which is a BGA 153 chip. And then it's got a setting, a way in here that I can set it in place, and it will lock in there. And then the nice thing is that this is magnetic on the back. And then this, which also, I have to make sure pin 1 is in the right direction. I can make sure that lines up. And then this is where having a microscope is I don't want to say it's required, but it is extremely helpful. So we are going to turn on our light here. And let's get into focus. And there you can see how important, so it's really important to have this all lined up and ready to go. Looks like I have some solder already down there on one of those, but that's okay. And now what we're going to use, actually let's swap back to my bench view. This is a first for some of this stuff on my channel. So obviously we're not going to be using our regular solder that's solid like this. We're going to be using this spreadable solder here, this solder paste, and then I've got this kind of spreader here that's just a little, it's literally just a piece of sheet metal. And so we're going to be applying this to the stencil, and then we're going to be making sure that the solder just lines up over top of the pads on our BGA chip, and then we will apply heat to the chip, so to turn it into nice little solder balls. So let's swap over here again and kick that off. So here we go, got my syringe of solder paste, and I don't mind like repeating this a couple times. It's actually not great to have a bunch of excess on here, because then they can turn into little rogue solder balls that attach to things that you don't want them to attach to. So I actually find it's better to clean it all off, and then I literally just wipe that solder paste somewhere, and then I just want to start again. Although that looks pretty solid. I don't think I really need any more than that. But let me just touch up a few areas here. Yeah, like down here on the left. That looks good. I like that. All right. And now we're gonna apply heat. So this is the fun part because it's all gonna, let me zoom in here. Get us nice and in focus. All right, so we're just gonna apply heat. And then like magic, it's gonna turn into a bunch of little solder balls there. Ugh, yeah, see I have one where I have like too much solder. That is not ideal. Yeah, this one right here is going to be highly problematic. Okay, what we're gonna do, I'm gonna attempt to heat this up and then wipe that off. Get off, get off, get off. No. There we go. Okay. We're gonna see how that one plays. All right. And then it's definitely important to let this cool off. You don't want to pull it off too quick. Man, see, this is what I'm talking about. These random little solder balls running around. All right. Let's come over to the bench. All right, so this, you kind of have to flex this off here. And now we're going to inspect and decide if that was good enough or if we need to redo it. It's possible we'll have to redo this, but we'll give it a look first. Okay, you know what? I think that's solid. Okay, so I can already tell that. Oh, wait a minute. Is this one not? Yeah. So that solder ball is not super great, and then this one is really big. All right. Let me look at it sideways at this. Yeah, there's a bunch that did not get really solid. All right, we're gonna redo it. I'm calling it. All right. So I'm gonna get some solder braid and some flux. So we're gonna do this over again. Yeah, first I'm just cutting off some braid off camera here to soak up my solder. Yeah, it's not fun to have to redo this, but what you really don't want to do is, yeah, reconnect it to the board and then find out then that that's what you need to do. All right, so we're gonna throw some flux down. All right, come on back. Come on back. All right, there we go. Nice and clean. Oh yeah, we do need to clean this off actually. Alright, so let's just make sure that's all evaporated. All right, now what I want to do is first I'm gonna take a paper towel, kind of wipe off that area, get all this solder out of the way, and then I might even want to clean off my stencil. You know, And make sure there's no solder like connected to this is what I also want to do. All right, I think I'm clear. All right, let's get ourselves lined up again. All right, pin 1 up and to the right. Pin 1 on my stencil. Up and to the right. Go. Back to our microscope. Let's be in focus here. That's solid. Okay. All right, let's go. Round 2 of solder paste. I'm gonna make sure I get off camera. I've got a paper towel. I just want to clean off this little piece of metal, sheet metal that is my spreader. So. Okay. Go back this way. Yeah, as you can see from the first time, like you really don't want too much solder paste because then the ball will kind of sit on top of the thing. But you don't want too little either. All right. Just a little bit more spots. That looks great, but okay. I like it. Let's throw some heat on it. There we go. Ooh, that is like money. That's the way it's supposed to go. All right, second tries the charm. All right, that's good. That's good. All right, now we can pull it off. Again, I want to let it cool, but I'm pretty sure it's cool. All right, gonna go like this. That is beautiful. All right, again, just inspect with microscope. Wow, those are great. I like it. Okay, so if there's a little bit of flux on there, it's like not the end of my day, but we're just gonna a little bit cleanup because we're gonna apply flux. You don't want too much flux in this process. You just want the right amount of flux. So let's go back to the bench. So now I need to bring the cameras front and center. My chip, make sure it's out of the way. All right. So here we go. Let me zoom in. Okay, so I got a bunch of solder in there. Need to clean that up. So plenty of flux. Braid and soldering iron. I've really been liking my new how do I get this in focus? Come on. My soldering iron there with the flat tip. It does a lot better at stuff like this. This kind of work right here is what it shines at. Doing this. I just want to glide. I just want it to glide over and pick up that solder. Okay. I know I need a little bit of flux on there, but I am actually going to clean that up because it's kind of getting a bit gross. And I just want to check. Like I'll throw flux back down, but I just want to check and make sure I've gotten most of the solder off of there. It's actually hard to tell with all the flux on it. Okay, back to microscope, back and forth. And oh man, oh yeah, this is like going to be at the range of my focus, so it might not focus great. But okay, we're starting to Yeah, I feel like I'm starting to scrape away here, so I'm gonna be extra careful now. All right, let me throw some flux down here. So we need a little bit of flux there anyway for when we throw our chip back down to put it back on the board. Okay, you know, we're great. So, okay, we got some flux down, perfect. And we're going to line up our chip, and I will do that underneath the microscope. Okay, we have pin 1 is bottom left, so I'll put chip, pin 1, bottom left. There we go. Now, yeah, that's a lot of flux, but it's okay. I'm actually gonna like smush it a little bit. You don't want too much because it like, I've noticed when I do this, sometimes the chip, you want it to float, but you don't want it to float away. All right, so now that is basically on target. And now we're gonna throw heat at it. And we're gonna reconnect this bad boy. All right. Right around. And that solder from the paste is nice low temp stuff. And so this should not take long. And now you can do a little push test. I can push. Oh man. How bad are we? How bad are we, man? We might have screwed it. All right. There we go. Ooh, it's not good. It's not good at all. There was too much flux. Whoa. Are my solder balls somehow okay? That would be the shocker of the century. All right, I think I screwed it up, but let's find out. Let's go look at this chip. Into focus, please. No, I'm pretty sure I jacked that up. Yeah. Yeah, no. Nope, it's messed up. We gotta redo it. All right. So the third time's the charm. Right? Right. Good. And then I'm gonna do this like, it's like I've got my wick out, so I'm just gonna do this while I have it here. That kind of a thing. I don't think like any solder stuck to here. Okay, yeah. What I did, I had way too much flux. I think I had way too much flux sitting here. And it just floated. It floated. It's like it was hydroplaning. All right. Okay. So, oh yeah. Gotta clean this up again. Let's clean up. Sure we got the top kind of clean. The bottom mostly clean. There we go. Evaporate. All right, third time's the charm. I'm gonna wipe my little piece of sheet metal off. All right, now back to the stencil again, which we will clean again. Yeah, just want to make sure that's nice and clean. Paper towel. All right. Yeah, because that's gotten me in trouble before too, when I don't when I do not properly clean that guy. All right, there we go. Pin 1, upper right. Pin 1, upper right. Okay, yeah, it's clean. Back to the microscope. Nope, back to the microscope. Yeah, not that zoomed in. And we're way off. Okay, good to know. Hey, there we go. Perfect. And we apply our solder paste. Earlier today, I got this first try. Now it's taking a bit. All right, that looks good. Looks clean. Nothing poking out. Okay, I'm gonna scrape it one more time. Just get the feeling that it's like, otherwise it's gonna do the thing where it sticks out. All right, applying heat. Good. That looks amazing. We'll let it cool. Back to the bench. All right. And you know what? Yeah, over here, in the meantime, I'm going to clean this off, and we're going to put a very fresh and a very thin layer of flux. Don't want it to be too thick. Use that before. All right, we're going to clean. Evaporate. Let's go. Nice clean spot there. And then, okay, so just checking again. Okay, yeah, my pin 1 is on the bottom left. Here we go. Those look amazing. So, oh yeah, flux. Okay. Just seriously a little bit of flux. Not very much. So small. Okay. Line that up. And then we'll just check the alignment for scope really fast, because it's not focused perfectly. Oh, there we go. Yeah, I mean, that looks perfect. Okay, that looks great. All right, I'll do it onto the scope. Here we go. Come on, NAND flash, let's go. Into place. Oh, there we go. Oh, no, it's going out of whack. It's going out of whack again. It's all jacked up. Come on. Let's go. Okay, now. Hey, we might have gotten it back. It's got its surface tension there. All right. I'm honestly not feeling too great about this, but let's see how it goes. All right, I'll let that cool just a little bit. Let's clear that out. Turn off my air extraction. Don't need that no more. Just gonna clean up here, and then we're gonna prep my UART cables. Let's go back. All right, so we got. Oh yeah. We gotta flip this because UART's on the other side. All right, we go like this. There we go. There we go. We got ground. Closer than that. And then I've got 2 little cables here. Got transmit on this side. Receive on that side. Okay, just doing a double check. All my wires look good. And then we will plug in the power over Ethernet in a minute. But first, let's go find ourselves a terminal. Okay, ready? The moment of truth. Whoa, all right. It read the NAND just fine. And we don't get the error. We don't get the error. I don't see the error. I don't think I see the error. Whoa. Guys, we might have firmware modification. Let's see what happens. There might still be something weird with binsh. Like binsh could be like sim-linked to like the protected shell, and then I could have to like change it again, which would be really sucky. Okay. Oh, it is. See, okay. Okay, so I'm still in the protect shell, but I want to see if we did successfully modify the firmware, because that in and of itself is a feat. All right, Control U, print env. We did update. We did. Look at that. We did successfully update our boot args. So binsh must be sim-linked to the protect shell. So I wonder if ash, like ASH, is actually the shell on this, or something else. But we will have to try that in another video. But I hope you can see that, yeah, doing this BGA reballing work, it is a bit tedious, but it is a big barrier that if you can't overcome it, you can probably do some types of analysis that other people can't do. But yeah, no, I'm disappointed and excited that I got a good, solid BGA reballing, and I showed you the mistakes and how I overcome those. It's very tedious, and if you rush, you're probably going to screw it up. And it was really cool there. So even when the chip, I thought that chip was gonna fail. When the BGA chip like went too far to the side, I was like, oh crap, like the solder is bridged under there and it's no good. But a lot of times, if there is flux down there, if you just keep throwing heat at it, it will go to the right place. So that was really cool to see. Yeah, I'm a little bummed that I'm gonna have to iterate on this, and I will make another video if I eventually get a legit root shell out of this. I wonder if it's got to be like ASH or something like that. I mean, let's just boot. Come on, man. We'll try one more time. I don't know why I think it would like do something, but. There's also like a prompt somewhere in the boot process where it's like, hit Control C. Maybe. Trying all the key combos, as you can see. All right. So obviously, we're gonna have to try some different methods of firmware modification, but you can see that the cycle is obviously take the chip off, put it in the reader, make your mod, and then the quite difficult task of BGA reballing. But hope you enjoyed this video. Comment, like, subscribe, tell me what you want me to do in the future. Have a good day.